user like 67% or 67 out of 70.
And
You don't even have
the
it up. Because you told me. Is that where you meant the ginger? How do you even need the ginger? Okay.
All right, ladies. Hang on a minute.
You're gonna keep that in your
Yeah, seems about right.
I missed it already. Did they? Well, they hit themselves.
Yeah, it's just one more picture of the icon.
We don't need to remember.
See, where's all the
They ate it.
All right, ladies and gentlemen. Let me hand back your stuff for you. That's the best place, I guess, to begin.
Did you know?
I think Mark Zuckerberg should just like all the flags in the world so we don't have to do it.
That one.
Hi.
Yeah.
Most like you should really do it.
Mason.
What?
Isaiah.
No, there's two art pages in one.
Aiden.
No, carbon. Carbon. I tried like Michael Jackson. Wait, is it band? Like BAND?
What?
For the music question. Is it Barry?
There were actually a couple answers that people came up with that could have worked.
I tried Michael Jackson.
I think we reached the ball.
Dante.
I got this one.
Joshua.
1, 2, 3,
Michaela.
4.
All right. So let's take a look at the tests real quick, ladies and gentlemen. All right. On the first page, ladies and gentlemen, you needed to do them all. If you put parentheses where there were not supposed to be parentheses, if you did not put a Q after acids, you did not get them right. So here are the first 10. Take a look at them. If you have any questions, please let me know.
Oh, that's what really helped. Yeah. Cheater, puppet eater.
Mark this one.
You're welcome. I just forgot the AQ.
Questions, ladies and gentlemen, on any of these?
For some reason, I thought HI was wrong because it just seems too obvious.
Why does that seem too obvious? Iodic comes from iodine. Symbol for iodine is I, last time I checked. So, any questions? Can I move on to the next one? Next page? Again, on the next page, ladies and gentlemen, you only needed to do 10 out of the 20 that were there. Okay. So there are those. It was a half a point for identifying if it was binary or ternary. It was a half a point for identifying if it was ionic, covalent, or an acid.
Ionic has a metal and covalent has no metals. That's literally just.
Be careful, there were some that had to be reduced. That's why there maybe are no subscripts by them.
Hey, Mr. Brand, what is our final exam gonna look like in here? Is it gonna be like a full summarized final?
I haven't decided yet.
Okay.
Ionic has metals and covalent has no metals. That's literally just.
Does anyone need any more time with this page? Rose, you need to take out your headphones, please. Thank you.
Bromine, uranium, hydrogen.
We're good? Again, on this next page, ladies and gentlemen, you only needed to do 10 out of the 20. You could have chosen any 10 that you wished. Right? And again, a half point each for the binary or ternary, half point each for ionic, acid, or covalent.
At least you have the number.
I will tell you, ladies and gentlemen, some people made some simple mistakes. And what I mean by that is they had formulas that were close to being correct, but sometimes you grab the wrong symbol. I had people give me Ti for tin instead of Sn. Boron and bromine got confused a little bit. Boron is a B, bromine is a Br. So please double check. Also, if you're struggling to find something on your periodic table, please raise your hand. Indium was one of those that we used in this, ladies and gentlemen, and I think people actually used iridium instead of indium for when they were finding their charge and things. So again, I will be more than happy to come over and point out where things are on your periodic table for you. And if you can't read something to spell it, you call me over and you say, Mr. Brand, can you spell that element? And I will spell it for you. Okay? But again, I didn't take off for spelling errors unless they were a major spelling error. If you spelled the wrong prefix, if you put the wrong ending on it, something like that. Questions on this page, ladies and gentlemen? Yes, no, maybe so. Can I move on to the next page? Okay. Again, you did need to do all 10 of these.
Oh my goodness. Like, I could feel it. Sheila? Your sister? You don't remember her? I've never met someone with my last name. Other than my dad, I guess.
Again, if there are ones that you think I marked incorrectly, please put a note for me. Recheck number, or, put a star by it and a little note that says recheck. And then on the front, you're going to put, please recheck page 3, page 4, whatever. Okay? Just so that I know what you want me to go back and re-look at. Number 5, when we add a prefix or suffix to a polyatomic ion, something changes in the formula and something that does not change. So what changes in the formula is the number of oxygens. What does not change is the charge, or I accepted the elements that were involved. Okay?
Yeah, no, you were in the right direction.
And by the way, by putting a prefix or a suffix, that insinuates that the name is going to change. So I did not accept that as one of the choices, because what I wanted you to tell me was the number of oxygens changing. Okay? And you can't say what stayed the same was the formula, because it actually changes. The number of oxygens change. Why do some acids have hydro in their name and some do not? They have hydro because they are binary. They don't because they're ternary. What is AQ? Why do acids have AQ after them? AQ means aqueous. I didn't want you to tell me that's what it meant. Why do they have it after them? Because they are dissolved in water. Okay? Acids have to be dissolved in water.
I got that one right.
And the last one, why do atoms combine? They combine to become stable, or I also accept it to fill their valence shell. Okay? Those were the two things. If you put to become charged, no, because some atoms become stable without becoming charged. They combine without becoming charged. Questions? Okay. Backside number 9, cation and anion are the types of ions. You can gain, lose, or share electrons to fill your valence shell. For number 11, my first answer would have been beryllium and astatine for beat. Some people put down barium and nobidium for band, B-A-N-D. Some people put down, which one was it? Nobelium and, where are you at? Tellurium for note. Accepted any of those. Beat, note, band, sure. Okay. Method of transportation, I was thinking carbon and argon to get car. Okay. Somebody put another one down that was, I can't remember if it was walk or something like that. I can't remember exactly what it was, but it was a method of transportation, so I took it. Okay. Why can this compound exist? Because two metals will never combine with each other. Why can't this one exist? Because it has a noble gas in it. Okay. And then why don't covalent compounds have to be reduced? Because they're sharing electrons, not gaining or losing them. Okay? Questions? The one thing I would ask that you please do, double check my arithmetic again. I do make mistakes on math, even though there were fewer pages in here. Make sure that I have added the number up on each page correctly and that the number in the corner of the page is correct. Because if that's not, that's what I add up to get to your number on the top and the front. So if I misadded on a page, that's going to affect your results. And if I misadded the corners together, that will obviously affect your results. And sometimes I add them together and I come up with 10 points too few. That happens sometimes. Please let me know if that is the case. Okay? So again, what we normally do at this point, ladies and gentlemen, is what we'll do right now, which is you're going to come up. If there are no problems with your test, please put them up here on this desk. If there is something that you want me to check, there should be a note on it, and then please bring it over here and put it on this desk for me. So check, good. Thank you. So again, good. If something needs to be checked, put it over there. Thank you, thank you. Thank you. Thank you, KB. Thank you, Morgan. Thank you. Thank you. Thank you. Yeah, don't worry, almost done with it. Not a problem.
You want the chicken from here? Great.
Are we good with it? Thank you, sir. I will give these back to you, okay? I will try to do so tomorrow, but this gives me a chance to give some people who weren't here yesterday the time to do the test today, okay? Some people are making other arrangements, and in spite of those, I will get you your test back tomorrow, ladies and gentlemen, okay? Yeah, where are they at? Okay. On the board, ladies and gentlemen, is what we're going to be doing today. We're going to move into Unit 4, but before we do that, let me give you this. On the bottom of the board, though, ladies and gentlemen, are 3 important dates for you. If there's anyone else who wanted to do a retake on Unit 2, you have till the end of the day tomorrow, and no, I cannot stay tomorrow after school, so you need to find a time to come in and do it. Missing work and any Unit 3 retakes. If you did poorly on the Unit 3 test and you want to do a retake on it, that has to be done by next week, Thursday, ladies and gentlemen. That is the last day that I can give you to do that because we are running out of time. We'll get you another one. Here you go, Dante. So, yeah, I know these timelines are short, but here's the fact. We are running out of time, ladies and gentlemen, with our semester. 2 weeks from today, you will be celebrating Thanksgiving or whenever you do it this time of the year. And hopefully enjoying a couple of well-deserved days off, ladies and gentlemen. So keep that in mind. Yes, and obviously that's not heavy test. Anthony? The grade that you should be looking at on here, ladies and gentlemen, please do not look at the one that says final grade. That was your grade when I had to put grades on the report card about 5 weeks ago. So what you should be looking at, ladies and gentlemen, is the grade that is your in-progress grade. That is the grade that you are actually at right now in the class, ladies and gentlemen. Okay? So that is your grade in the class. These are yours to keep, ladies and gentlemen. Okay? I do not need them back. But the one thing that I would tell you, ladies and gentlemen, when you look at this, go down to the bottom. Anything that you are missing in quizzes, anything that you are missing in labs, anything that you are missing in tests needs to get made up, because if it stays a 0, your grade will stay where it is at. If you do those things, even if you do them and don't do them very well, but you complete them and turn them in, your grade will go up, because right now your grade is a 0 on anything that is missing for me. Okay? Now, please remember, homework is not counted toward your grade. Okay? Questions? Yes, no, maybe so. Okay. Any questions about these things, ladies and gentlemen? By the way, please remember, if you ever need to do a retake for me, you need to do corrections to your original test. Can't do those until I give it back to you. And then when you do corrections, all you need to do is put the correct answer next to your original answer. Please do not erase your original stuff. Please put the correct answers next to it so I can easily see the changes that you make. Okay? Questions? All right. I gave you a new EISN, ladies and gentlemen. So go into Google Classroom, go to the classwork tab, and you will see that we have Unit 4 stuff there right now, ladies and gentlemen. And we are going to talk about balancing equations, or writing and balancing chemical reactions, however you wish to describe it. Here are the master notes, the ones that I am about to present to you, ladies and gentlemen, already online, waiting for you. Here is your new EISN. Please open it up. You do not have to turn in your old one. Up at the top, ladies and gentlemen, are the class teaching videos and the chemistry daily agenda. I am going to combine these in the second trimester. What I mean by that is I will make one calendar and it will have the agenda on it, and then it will have the video for the class that we did that day. I'm going to try to keep doing videos each day that we do, because I take them, I put them up on YouTube. If you need to, you can use them. If you don't, please feel free. You don't have to. But even the class teaching videos, ladies and gentlemen, I have already added the part for Unit 4. There obviously is no video from yesterday because I didn't video the test. But here will be the stuff for Unit 4 for you as well, just so you know. So if you miss a day, again, it's a shortened time frame. If you're homesick, after first hour, by 10:30, by 11 o'clock, I have the videos posted for that day, unless something goes wrong with me taping at first hour. So even if you're at home, you can watch the video, you can see what we did in class that day, and then when you come back, you will not be as far behind as if you did nothing, ladies and gentlemen. All right, so here we go, ladies and gentlemen. The things that we are going to look at in this unit, we are going to balance chemical equations. Okay, now I know that in physical science lately we haven't been doing a lot of this, so for some of you this may be new. We will work on it. We will give you some time doing it. We're also going to look at types of chemical reactions. So when we do this, there are 4 basic kinds of chemical reactions we will look at. Those you were introduced to in physical science if you took physical science here. The same 4 kinds that you were introduced in physical science we're going to be doing here. Now, 2 of those 4 types, synthesis and decomposition, I have to give you those reactions. There is no way that you will be able to predict those. But 2 types of chemical reactions, a single replacement and a double replacement. We will be writing those, and you will be predicting what is happening during those reactions. You will be predicting the products of them. You will be predicting if a reaction even happens. And we will show you how to do that. Okay, so that is why the slides 20 about predicting a single replacement reaction and 26 forward, predicting a double replacement reaction will be what you have to do. Okay, I haven't decided exactly on the final yet. I will let you know more about the final next week, ladies and gentlemen, as far as what we'll be doing. We will be having one. The question is, what will I be doing in it? That I haven't completely decided yet, ladies and gentlemen. So, because of the shortened time frame of this last unit. All right, so let's talk about balancing chemical equations, ladies and gentlemen. I don't care if you call them chemical equations. I don't care if you call them chemical reactions. They mean the same thing. A chemical equation is a description of a chemical reaction. Okay? We put things together and sometimes they react, sometimes they don't. We showed you one of these in the last unit when we did the aluminum and the copper 2 chloride. We took and we put those things together and we created aluminum chloride and we created copper metal. Okay? That is a type of reaction that you are going to eventually be able to predict from looking at the reactants as to if it will or will not happen. Okay? That is one of the things that you are going to be doing. We've already talked about signs that a chemical reaction happens. A gas is released, a precipitate forms, a change in energy, and unexpected color change. Now, of all of those things, there's only one that we can look for on paper. Only one that we can look for on paper. And that is a precipitate forming. We will show you how you can predict if a precipitate will form. Now, if we were doing a P-Chem, we might get into the thermodynamics of it and be able to predict if energy was gained or lost, but not in this class. Okay? All right. So why do we balance a chemical equation? Chemical equations must be balanced. And why must they be balanced? To support the law of conservation of matter. The law of conservation of matter says matter cannot be created or destroyed. It can only be changed. And that is what is happening during a chemical reaction. You're beginning with this stuff over here, and you're making this stuff over here. Now, the things that you begin with go into making the things that you end with. And you can never make more stuff than you began with. You can never have less stuff at the end than you began with. Okay? And that allows us to not only predict what will be created, but eventually how much of it. And we will get to that point eventually as well in this class, ladies and gentlemen. Okay? So what we're saying is the mass before a reaction has to be equal to the mass after a reaction. Now that doesn't mean everything needs to combine. Okay? There could be leftover stuff, things that didn't react. But what it does mean is no matter what, if we begin with 100 grams of stuff at the start, we got to end with 100 grams of stuff at the end. No ifs, no ands, no buts. Okay? You cannot create stuff. You cannot destroy stuff. Now, stuff can leave a reaction. You create a gas. Where's that gas going to go? Into the air. Now, that doesn't mean that you broke the law of conservation of mass. It just means you couldn't collect everything that you created in your reaction. Okay? Just means you couldn't collect everything that you created in your reaction. Okay. So this is a chemical reaction, ladies and gentlemen. Okay? This is a chemical reaction. Anybody remember what kind of chemical reaction this was from physical science? Where you have two things coming together to make one product? Let me give you the four kinds. Maybe it'll help. We gave you synthesis, decomposition, single replacement, double replacement.
Synthesis?
This is a synthesis. And if you had me as a teacher, ladies and gentlemen, this is the high school dance where you meet somebody at the dance and you become a couple. Okay? I related
Or Barbie and Ken get together and become a couple.
Go away. Nobody cares. Go, 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 go.
Anybody in here?
Barbie and Ken, no. No, no.
No, I didn't have a single person.
That's why I didn't bring it up.
Oh, okay. Hi.
Okay? So, my example is much cooler than hers. Okay? Point is, ladies and gentlemen, this is a reaction where you have two lone elements come together and make a compound. They come together and they make a compound, ladies and gentlemen. One thing is created. By the way, anybody know what this reaction is?
Oh, wait.
Oxidization.
Okay, what is it more commonly called in our everyday life?
Rusting.
This is called rusting. This is the reaction that creates rust, ladies and gentlemen. This is the reaction that creates rust. Okay. Now, before we go any further, ladies and gentlemen, I need you to add something to your periodic table. So take out your periodic table real quick, ladies and gentlemen. Take out your periodic table real quick. All right. Now, in the last unit, ladies and gentlemen, we taught you how to write the name of that compound at the end. What is the name of that compound at the end? It is an ionic compound. It is a binary compound. What would the name of Fe2O3 be? We'll do it without the Roman numeral for now. Iron oxide. What would we name the first element here? Iron. What would we name the second? What's unusual about the oxygen? No.
2.
It is O2. It is O2. There are what are called, ladies and gentlemen, 7 diatomic molecules. Okay, there are 7 of these. What does di mean? 2. Atomic.
Atom.
2 atoms making a molecule. But this is not a binary compound, because a binary compound is 2 different elements coming together. A diatomic molecule is this right here, ladies and gentlemen. O2. 2 oxygen atoms combining together to make a molecule of oxygen. In other words, we will never, ever, ever, if we are talking about just oxygen, have oxygen be a single atom alone. It is too reactive. In other words, if there's nothing else for oxygen to react with, it will literally react with itself, share electrons between 2 oxygen atoms, and become stable as a molecule. And there are 7 elements on the periodic table that do this. So I would put these down somewhere on your periodic table where you are going to be able to find this very easily. The 7 diatomic molecules are H2. Okay. Now, lithium cannot be one.
Oh, wait, no, because they want to lose electrons.
Correct. So diatomic molecules which end up sharing electrons have to be nonmetals. So N2, O2, F2, Cl2, Br2, I2. These are the 7 diatomic molecules that whenever we would write fluorine reacting, iodine reacting, we will have to write them as I2Br2O2 in a formula. Okay? Now, on this periodic table up here, they're the ones in the dark green. Hydrogen, nitrogen, over to fluorine, and then down to iodine. They're the 7 most reactive nonmetals. Okay? And they are so reactive that they will combine with themselves even if there is nothing else around. Okay? Now, this is very important because if you do not write their formulas correctly, when you go to balance a chemical equation, you will not write it correctly. This is only if they are alone. If they are combined with something, it might be NaF, 1F alone in a compound. Okay? It is only if they are not with anything at all, ladies and gentlemen, that we write them this way. Okay? So in a compound, we would do what we normally do, which is if it's an ionic compound, we would do our crisscross method. Okay? These are only if these things are alone. Questions? Okay. All right. All right. first of all, the parts of a reaction. The things that are before the arrow are called the reactants. They're the elements or compounds before the arrow that will react in the reaction. Element or compound? How do you know?
See a little.
How do you know?
I just.
How do you know? When you element or compound? Element or compound? Element. How do you know?
There's one there.
Thank you. Well, let's be a little more specific. Thank you. One capital letter. That's what I wanted for you here. So if you're looking and there's one capital letter in it, it is a element. Okay? It is an element. If they keep hitting the floor, I'm going to ask you to put them in the thing. So please, put them away. Okay? Element, element. Element or compound? Compound. When we are going to be identifying the kinds of reactions that are occurring, ladies and gentlemen, we need to know if things are an element or a compound. Okay? Things are an element or a compound. Now, please remember, if we are talking about eventually predicting this, what kind of compounds can we predict? Binary, ionic, or let me rephrase that. Ionic or covalent? Which one of those can we predict? Ionic or covalent? Because covalent do not have to be reduced, I would have to give you the name. Because ionic, I could tell you take this metal and this non-metal and make a compound out of them. We can predict those. Okay, we can predict those. I can't say take phosphorus and oxygen and make a compound out of it. You don't know how to do that. I've never taught you how to do that. I'm not going to teach you how to do that. So if that is the case, I have to give you the name of that compound. That's the only way you could write it. But if I say put beryllium and fluorine together, you should be able to write a formula for that based on the charges, based on the unit that we just finished. Okay? So reactants are things that are before the arrow. Products are the things that are after the arrow. And again, they are either elements or compounds. Those are your only two options. It is either an element or a compound. Okay? So, reactants before, products after, which means what separates these things? The arrow. Okay? The arrow separates these things. The two, the three, those are called subscripts. Those are created to balance the compound and indicate the number of atoms in the compound. You and I cannot change those. Once we write a formula and we have it balanced so that the total charge is what? 0. We cannot change this anymore. We cannot go and change this. We have to leave it. Okay? So we cannot change subscripts to balance a chemical equation. Again, I showed you this a little bit at the end. The M, the G, the S. Those are states of matter, ladies and gentlemen. Those are states of matter. Okay? Now, M stands for metal. G stands for gas. L for liquid. S for solid. Sometimes you will see CR. CR means crystalline solid. I am not expecting you to know when something is a crystalline solid. Okay? I will teach you how to know when something is a solid. And most of the time, if it is a compound, it will be aqueous. Okay? It will be aqueous. Unless the few times we predicted it becomes a solid. And we will show you how to do that. Okay? This becomes very important when we're talking about predicting double replacement reactions. Okay? Now, in front, ladies and gentlemen, are the coefficients. Coefficients you can change. Coefficients you control. Coefficients you decide what number to put there. As long as it ends up balancing the chemical equation. And what I mean by balancing, how many atoms of iron are here with a 4 in front? 4 of them. The 4 multiplies that. This says there's 1 atom of iron here, right? The 4 in front says multiply that by 4. Over on this side, in this compound, how many irons are there?
4.
In the compound, just 2. So we have a 2 out in front. To do what? Multiply that 2 to get a total of 4. How many oxygens are over here? All total. 6. 3 in the compound. 2 of these compounds means there would be 6 of them over here, correct?
Oh, true.
How many oxygens here?
6.
That's what we mean by a balanced chemical equation. The amount of oxygen on this side is equal to the amount of oxygen on this side. The amount of iron on this side is equal to the amount of iron on this side. We can't change these numbers to make it so. We put these numbers in front to make it so. Questions? Okay, real quick. I don't have it on the slide. Arrow separates the two sides, reactant and product. What does the plus sign do? No,
Atom.
no, it does not. It doesn't say atom. Because when we look at it, you're not necessarily going to add everything on one side together into one product. What it does do is it separates one reactant from another or one product from another. Okay? So it separates reactant from reactant. It separates product from product, ladies and gentlemen. Okay? So I know mathematically we would add those together. And you're like, well, Mr. Brown, here they're put together. Doesn't mean atom. Okay? Doesn't mean atom. It means this is a separate thing from this. Okay? And you'll see in a little while that more than likely you're going to have a plus sign on this side as well. Okay? Questions? Did you say, was there?
Is the extra plus sign on the products for like the gas that's released? Or whatever?
The extra plus sign.
Or like when we do add the plus on the product side.
It would mean there would be a second product created. Okay? Not necessarily gas, just a second product created. Okay? This kind of reaction, there's only one thing created. Single replacement, double replacement, there will be 2 products created. 2 different products. Okay? All right. So before we can balance equation, ladies and gentlemen, we need to learn how to count atoms. It's not difficult. How many Fe's, how many irons in this compound? 2. How many oxygen? 3. Good. What are the different elements in this compound? What are they?
Sodium, nitrogen, oxygen.
How do you know when you hit a new element each time, KP?
Because it's a capital letter.
Thank you. Good. I'm sorry. I'm being very basic with this. I know you guys know this, but I want to make it clear. Every time you hit a capital letter in a formula, that means that it is a new element. Na, N, and O are the 3 elements involved with this. How many NAs? 1. How many N? 1. How many O's? 3. Okay? Why 1 Na? Because there's no number by it. That means there's only one of them. Why 1 nitrogen? Because there's no number by it. That means there's one of them. Questions? All right. What are the elements involved in this compound? Calcium, carbon, and oxygen. Calcium, carbon, and oxygen. Keanu, yes.
How do you know that there's 3 different types for like Na and O?
Okay, because of what KP just said. Every time you hit a new capital letter,
But then
that's a new element.
nitrate.
What?
N, O.
That doesn't, for this, it doesn't matter. This is a nitrate compound. To balance equations, I am not worried about what compound is there. I'm worried about what elements are there and how many. Okay? So you are correct. This is nitrate. But a nitrate is made up of 1 nitrogen and 3 oxygens. And that's what we're breaking this down into. The individual atoms that are involved in the entire reaction. Because on one side it may be nitrate. On the other side it may be something different. Okay? But we still have to account for every nitrogen, every oxygen, every sodium atom in the compound. Okay? All right. CaCO3. Again, how many CAs? 1. How many carbons? 1. How many oxygens? 3. Good. Okay. Here, what are the elements involved? Nope, you're right.
Carbon, hydrogen, oxygen.
Magnesium, carbon, hydrogen, and oxygen. How many magnesiums?
One.
One. Nothing by the magnesium means there's one. Okay? Now the question is, what does this parentheses and the two after it do to this group? Multiplies that, it distributes out, like you're saying. It says there's actually two of those groups, or three of those groups, or four of those groups. It depends on what you put by it. So the number outside the parentheses distributes or multiplies everything inside by that many. So originally there are two carbons here. With the two outside, that makes it 4. There are originally 3 hydrogens here, but the two outside makes that 6. And there were 2 oxygens with the 2 outside, that makes it 4. Okay, that makes it 4. Okay, now again, KP and everybody, the magnesium is not within those parentheses. So we do not multiply it by the 2. Only the things that are inside the parentheses get multiplied by the number that is outside of it. Questions? Now, again, here, we've got calcium, we've got phosphorus, we've got oxygen. How many calciums? Try again. 3. How many phosphorus?
1.
I agree, 1 there, but in the parentheses, we got to multiply it by the 2 outside. So there are 2 of them. How many oxygens? 8. So this number outside the parentheses multiplies everything inside, every different thing inside by that number. How do I know when there's a different thing? Look for capital letters. P and O are different from each other. Questions? Okay. Now what we've done is we've put a coefficient in front. Okay. Now we put a coefficient in front. Let me do this before I forget. All right. There we go. All right. So without this coefficient in front, how many zincs?
1.
How many, hang on. Never mind, I'm just on the last screen. Let's try this again. 1. How many chlorines? 2. When we put a coefficient in front, it multiplies all of these by the coefficient. So now how many zinc? How many chlorine? 4. So in parentheses, the number outside the parentheses multiplies what is inside the parentheses. But a coefficient in front multiplies everything after it. So without the coefficient, without the 3 here, how many bariums? 3. How many nitrogens? 2. Now we put a 3 in front of it. What does it do to the number of bariums?
Multiplies it by 3.
So there are 9. And how many nitrogens? 6. Okay? Now, again, this is a basic. If we can't get this down, you are going to struggle to balance chemical equations. Because you get to decide what number you're putting in front. But the reason we're going to put a number in front is maybe there's only 1 barium on one side of the reaction and on the other side there is 3 of them. We need to increase the amount of barium on one side. We put a coefficient in front of it. Okay? All right. So again, we've got strontium, carbon, hydrogen, and oxygen. Without the 4 in front here, without it, how many strontiums? 1. How many carbons? Be careful here.
4.
4. The 2 inside times the 2 outside. Okay? How many hydrogens? 6. How many oxygens? 4. Now when we put that 4 in front, it multiplies all of those numbers, every single one of them, by 4. So instead of 1 strontium, there are 4. Instead of 4 carbons, there are
16.
Instead of 6 hydrogens,
24.
and instead of 4 oxygens, there are 16 of them. Questions?
How'd you put
All right. Any questions at all? Okay. So let's take a look at balancing a chemical equation. We do this because it supports the law of conservation of mass. A chemical equation is balanced when the same amount of each atom on both sides of the equation. When there are the same number or amount of each atom on both sides of the equation. Let me explain what we mean. You cannot change formulas to balance an equation. We can't make H2O, H3O just because we want to balance something. We cannot change subscripts. You cannot do that. Subscripts were determined to make the compound have a total charge of 0. Or because they're sharing electrons between atoms and this is the way they're sharing them to make this compound. We can add and we can change coefficients. That we can do. And that will be enough to balance a chemical equation. Balancing is a trial and error process, ladies and gentlemen. I'd love to tell you this is how you go about balancing an equation, but there is no set method to do it. It is look at your numbers, put something in, see how it changes things, and you work through until you get it to where it finally works out. Now, here's the good news. After a while, you will recognize certain patterns and things, certain ways of putting your numbers in so that they balance things out very easily. Okay? It just is going to take a while. Okay? It is just going to take a little while. Here is the one thing I will tell you, ladies and gentlemen. If you write a formula wrong, if I tell you this reaction produces sodium nitrite, NaNO2, and you accidentally write sodium nitrate, NaNO3, you may never get that reaction to balance. No matter what you do, it may never balance out. In which case, you're going to sit there and you're going to be like, Mr. Brand, this one doesn't balance. You cannot balance this one. And I will be, you're right. Now, check your formulas. Find out which formula you wrote down incorrectly and then redo it. Because every equation I give you will balance. But not if you don't write the right name. Okay? Let me rephrase it. Not if you don't write the right formula. All right, so here we go, ladies and gentlemen. This is a chemical equation. It is not balanced. How many magnesiums are here? How many are over here? Not balanced. We know that right away. So I'm going to teach you a method that I like to call the scoreboard method. In other words, right underneath the arrow, I am going to put a scoreboard there. And I want to end up with a tied game. I want to end up tied on both sides of the scoreboard. So we're going to count up the number of atoms of each element on both sides of the equation. We are going to add coefficients if you need more of an element on the side. So like right now, I don't have enough magnesium over here. I'm going to end up having to put a coefficient in front of it. Okay? You stop when both sides have the same amounts on each side. I'll show you what we mean by that. Now, while it is trial and error, I will give you a few hints. Number one, start with elements that there is only one way to balance them. I'll show you what I mean by that. Leave elements that are in many spots until the end. In other words, if you have hydrogen or oxygen in 3 out of the 4 spots, it's a bad element to begin with. Don't begin with it. Okay? Begin with something else. Save lone elements for last. I am not going to put anything in front of magnesium right away. Here's the reason. When I put a number in front of it, what do I change?
How many pairs?
Yeah, but just the magnesium, right? If I put a number in front here, what changes?
How many
Magnesium,
and
phosphorus, and oxygen. So when I put a number in front here, it changes a lot of things. Save this for the end because you know what? If at the end I need a certain number of these, I can put that number in front. Boom, I'm done. Okay? So I try to save my lone elements to the end. And please remember, if you have 2 of something on one side and 3 on the other, what's the smallest number that you can get both of those 2? 6. So we will have to do that. And that happens a lot. And you may be going, well, why would you have 2 on one side and 3 on the other? Well, because that's just the way it is. In the compound, sometimes you need 3 of something of one time and 2 of something another. Okay? So here's what I mean by my scoreboard, ladies and gentlemen. Right underneath the arrow, I list all of the different elements that are involved in the compound. Magnesium, hydrogen, phosphorus, oxygen, all separated here. And Keanu, this is why I separated the phosphorus and the oxygen, the phosphate group. Okay? Because I want to keep track of how many of these things there are on each side. Okay? All right. So, to begin with, how many magnesiums on the reactant side? 1. 3 on the product. How many hydrogen on the reactant side? How many on the product? 2. Okay? How many phosphorus on the reactant side? Product. Okay? How many oxygen on the reactant side? Product. 8. By the way, if you mess this up, guess what? It's not going to balance. Okay? It's not going to balance. So you've got to be very careful with your math here. Now again, I am really hoping you don't need a calculator for 2 times 4. But if you do, take it out and use it. Okay? Take it out and use it. All right. So when we look at this right now, ladies and gentlemen, right now, is everything the same on both sides? In other words, ladies and gentlemen, are the number of magnesiums the same on both sides? Is anything the same on both sides? No. So we are going to have to start somewhere, ladies and gentlemen. Okay? Now, the only thing that I want to do is I want to save magnesium till the end. I want to do that last. Okay? And again, I explained why a minute ago. Because it's a lone element, I can put any number I want in front of it and it's not going to mess up anything else. Other than that, pick something. Anthony, pick an element other than magnesium. All right? Let's get hydrogen to balance. Okay? So I have 3 hydrogen on one side. I have 2 on the other. What is the least or the smallest number that I can get both to that would be the same on both sides? 6. This is going to happen a lot, ladies and gentlemen. You are going to have 2 on one side and 3 on the other. So we have to get to 6. And the way we get to 6 is the side where 3 is the subscript. What has to be our coefficient? 2. So I'm going to put a 2 in front of the H3PO4. When I do that, now I'm going to come down and I'm going to do what I call updating my scoreboard. There are no longer 3, 1, and 4 of these. How many hydrogens are there now? 6. How many oxygens? Or I'm sorry, phosphorus. Let's do that first. 2. How many oxygens? 8. Hey, good news. We got oxygens balanced. We got phosphorus balanced now. And we weren't even trying to do those. Anthony wanted to do the hydrogen. Okay. So what do I do on the other side where there is a 2 as a coefficient, 2 as a subscript here? Put a 3 for a coefficient. How many hydrogens? 6. Okay, what's left? Okay, so what do I put in front of magnesium here? It will work out every single time, ladies and gentlemen. Your balancing will work out every single time. Now, let's say Anthony, instead of wanting to start with hydrogen, wanted to start with phosphorus. How would we get more phosphorus over here? We would have had to put a number in front here anyway, right? We would have put a 2 there anyway. Everything would have worked out the same. Okay? It doesn't matter where you begin. Even if you were to begin with magnesium, it would have worked out. Everything's got to get balanced. And if you wrote everything correctly, ladies and gentlemen, it will get balanced. Questions? Sorry. Okay. So here we go again, ladies and gentlemen. This is just in a little bit of a wrong spot here. All right. It already showed you this. But first thing you're going to do is you're going to take your inventory. How many calcium on the reactant side here? 1. On the product? 1. How many silver on the reactant side? 1. How many on the product? 1. How many nitrogens on the reactant side? 1. How many on the product side? Please be careful here. 2. How many oxygens here on the reactant side? And on the product? Okay. So there's only 2 things that we need to balance. Nitrogen and oxygen, right? This is the compound that has nitrogen and oxygen on it on the side that we need more. That is the other reason, ladies and gentlemen, that I put this scoreboard right underneath, so that I can keep track of side to side. Okay? I need more nitrogen and oxygen on this side. Which one do you want to start with, nitrogen or oxygen? Go ahead, Josh. Okay, so what number am I going to put in front here to get me 2 nitrogens on this side? 2. By the way, start with small numbers. Don't put in 12. Most things will balance with 2s, 3s, maybe 4s. Some will take bigger numbers, but start out with smaller numbers. So I'm going to put a 2 in front of the AgNO3. Now, what did I change? How many? I didn't want to change it, but it did change. How many nitrogens? How many oxygens? Okay, so what do I do to finish? Put a 2 in front of the silver on the right side, on the product side. I don't care how you say it. From 1, we go to 2 now. Now you have a balanced chemical equation. Now you have a balanced chemical equation, ladies and gentlemen. And that is what we are always looking for. That is what we are always trying to find. Questions?
Are we able to shove the 2 in between the silver and the nitrogen?
No, you can't. No, you can't. Good question. Couldn't I just shove the 2 in between here? No. Because what would that be saying? That there are 2 more of these groups attached to this 1 ox or 1 silver still. Can't do that. The coefficients have to go in front, and they change how many of the compounds are there, not the compound itself. Okay? So good question. You can only put the coefficients in front. Questions? All right. How many aluminum on the reactant side?
1.
Product side? 1. Copper reactant side? Product? I didn't hear it if somebody said it, sorry. 1. How many oxygens on the reactant side? Product? Hydrogens? Okay, the only thing we got to balance is the oxygen and the hydrogen, right? Which one do you want to start with? Okay, here's the compound containing O on the reactant side where we need more. What number do I put in front? Okay, what changed? Everything. No, everything did not. Copper, how many? What else? 3 oxygen, 3 hydrogen. Okay, what do we do to finish? By? Where? On the product side, on the right-hand side, however you want to say it. There you go, ladies and gentlemen. That is a balanced chemical equation. Questions? Gosh, I hope the next one is more difficult. I know you may not, but
This is boring.
what?
This is boring. For you.
No, but these are easy. Well, sorry. I shouldn't say that. To me, these are easy right now. Hopefully to you, they're easy. They're going to get a little bit more difficult. Ooh. By the way, what number don't we ever write in front? We don't ever write ones. We should know that by now. I put them in here so you could see what they would be, but we never write ones, ladies and gentlemen. Never write ones in front. All right, here we go. This one gets a little bit more challenging. I should take away all the stuff that's on there because it doesn't match for this. All right. All right. All right. So here we go, ladies and gentlemen. We only have 3 elements here: carbon, hydrogen, and oxygen. Okay. How many carbons on the reactant side?
4,
How many on the product?
1,
1. How many hydrogens
10,
on the product?
2,
How many oxygens on the reactant side?
2,
Okay. How many on the product?
3.
Good. When you have an element that is in 2 spots on one side, you have to figure out how many are in one spot, how many are in the other spot, and that is the one time when we add them together. Okay? That is the one time when we add them together. So there are 2 oxygens here. There is 1 oxygen here. That means that there are 3. There are 3. Okay? Now, this one is going to let us do a couple of the tricks that I have shown you. Number 1, I'm going to try to save the lone element for last. What's the lone element? Oxygen. Going to try to save that for last. Okay? Number 2, I'm going to leave elements that are in a lot of spots till the end. What element is in a lot of spots here? Oxygen. Okay? Now, the reason for that is if I put a number here, it's going to change the amount of oxygens. But then if I have to put a number here, it's also going to change the amount of oxygens. So I'm going to try to leave that until it's one of my last choices. Okay? Now, where, without oxygen, do you want to start? Which one? Carbon? Okay. All right. I have 4 carbon on the reactant side. How many do I need on the product side? So what do I put in front here? Now I'm going to update. How many carbons? All right. Now, careful. How many oxygens here? 8. But we still have 1 here. So what's the total? 9. I'm still not going to balance oxygens yet. Saving it for the end. Okay. What number do I put in front of the H over here to get hydrogens to balance? 5. Remember when I said most balance with 2 3s and 4s? Yeah, well, this ain't one of them. Okay, no. I said some of the numbers do get larger. So how many hydrogens here? 10. Now, how many oxygens up here? 5 here, right? So how many on this side? Let's try our math again, please. 8 and 5 is 13. Okay. Again, maybe you have to pull out the calculators. Hopefully not. Okay. All right. So now, here's the nice part. I saved this for the end. I saved my oxygen until the end. Okay. What number do I put in front of oxygen? Okay, I didn't think that was that hard a question, ladies and gentlemen. Let me rephrase the question. What number times 2 will equal 13? 6.5. Does that equal 13? You bet. Now, one problem in the last 45 seconds of class. Hey, we're not done. Because you cannot leave this 6.5 in here. We put it in there to balance it, but we cannot leave it here. So, we can't round it. How would in math class, you get rid of a 0.5 in an equation. We would multiply everything by 2. And that is what we are going to do here. This becomes a 2. This becomes 13. This becomes 8. This becomes 10. Boom, it's still balanced. Still balanced.
He's just making up stuff now.
Yeah, making stuff up to balance this equation. Have a great day, ladies and gentlemen. We will see you tomorrow.
Mister,
Yes.
you never even gave me a charger, Bob.
You think I remembered? I'm sorry.
I know I didn't want to interrupt you because you was teaching,
Andy,
so I
hang
just sat there. But
Evan, hang on.
can I work on my test correction?
Certainly, you can stay. Here you go.
Can I do my test too? You. Oh my goodness, she was here this whole time.
Did you get done?
I'm pretty much done, but I kind of just want to like check over everything. Can I come like after school? Just because I want to make sure that I like.
Okay, but I'm only going to give you a few minutes because I only
Okay.
give everybody the hour to do
Okay,
it.
yeah.
Okay, so just set it there. Okay, Evan, here you go.
Can I do my quiz or test?
Well, which one do you want to do? It's 100% up to you.
I don't know. Can I go to the bathroom? Can I do the recent quiz?
Go ahead. All right,
Wait, I don't want to be late. No.
you're coming right back to my room. The bathrooms are literally behind the door there,
Okay.
behind the wall. Go.
Okay.
You should be able to go to the bathroom and get back here for.
No, you don't understand. Those stalls be packed. Maybe I should wait.
You don't know, because then you're going to wait 10 minutes through the hour. Then you're going to go to the bathroom, and out of 20 minutes, you'll spend 5 minutes in there, and you won't get any help.
Okay, okay.
All right,
Can you
Michaela, which
email
test?
My Mr. Quiz.
I won't have to. I'll send a note to attendance. Don't worry. Go.
The recent one.
You got 3-1. You got 3-2. So you want the second quiz or you want the first quiz from the third unit? First one was on binary ionic compounds. Binary and ternary. Binary and ternary? Or just binary? Yes, binary and ternary ionic compounds. The second one was on everything. All right.
Hi.
Be Thursday the 16th. That's it.
Is it this week or next week?
That's next week. There you go. Go ahead and go to work. Yes.
Can I use the bathroom?
Go, hurry up.